Hi everyone, this is Jayashree, Assistant Professor, Department of IoT. So in this lecture, we discuss upon ElGamal Cryptosystem. Okay, so ElGamal Cryptosystem is for secure transformation of information in an insecure network. Okay, to transfer data in an insecure network, we use ElGamal crypto system. Okay, so this ElGamal system, the technology is similar to Diffie-Hellman key exchange. Okay, so what happens in a Diffie-Hellman? A key shared publicly open to everyone. What a key shared between a sender, receiver, and publicly. And there is then another key is exchanged privately. Okay, so that like that. Here, this ElGamal crypto system works using discrete logarithm technique. Okay, so in Diffie-Hellman also, discrete logarithm is used for safe transfer. Here also, ElGamal crypto technique uses discrete logarithm from mathematics, right? So before going to the topic, what is encryption? Okay, so what are the different types of where encryption is used? We all know it is in WhatsApp status, online banking, OTPs, digital signatures. These are all the things we discussed in the last class, right? So objective of today's section is students will be able to understand the mathematical foundations of ElGamal crypto systems, that is discrete logarithm, then explain its key generation, encryption, and decryption. So, main in ElGamal crypto system consists of three steps. One is key generation, second is encryption, third one is decryption. We discuss upon those. Then next is apply it in simply encryption decryption scenarios. Okay, mathematical examples, right? So problem statement, imagine there is a person, a Ravi, a cybersecurity analyst, right? So he needs to implement a secure encryption scheme for transmitting data over an insecure cloud network. Okay, then how he can transfer the data in an insecure network? So that is the scenario here. So here the problem statement is how can we design a public key encryption mechanism that ensures confidentiality and security based on mathematical hardness such as discrete logarithm problem. So discrete logarithm is used here for in implementation of ElGamal crypto system, right? So to empathize. So what is empathize? Users point of views we tell that is empathize. So users here users are organizations and developers, right? So users want data confidentiality and authentication in online transactions, right? So that is one point. Next main concern here is how to prevent attackers from deducing private keys from public information. So, okay, what happens if an attacker steal the private key? What happened to the information? So that is the empathy part here. Next, define. So what is define? The main challenge is designing on a secure non-RSA public key encryption method. So that the method should be a non-RSA public key encryption, right? It must be computationally hard to break, scalable, and randomized to avoid pattern prediction. Okay, right. So it should be robust. It should be computationally hard to break the key. So that is the defined part here. So the ideas. What are the ideas for that problem? One is RSA. Okay, so RSA based on factoring prime numbers. You all know we have studied. Then next is elliptic curve cryptography. This is another idea. Next is ElGamal based discrete logarithm over finite fields. So this is the third point. That is ElGamal based discrete algorithm. So this thing we are going to discuss in this topic. So what is that ElGamal based discrete logarithm? So look into the steps. First one is key generation. Okay. In that, for key generation, we initialize some parameters. Let's take q as prime number, one prime number as q. Then alpha is the primitive root of q. That alpha should be less than q. Next, for key generation by Alice. Alice is sender, Bob is receiver. Okay, right. Then key generation by Alice. So select private key XA. So private key select private key XA such that XA is less than q minus 1. Then calculate y suffix a. What is my ya? Ya equals alpha to the power xa mod q. Okay, right. From that, you can generate public key. What is my public key? Q, comma alpha, comma ya. So this is my public key. But then what is my private key? XA. So this thing we randomly selected SK, that should XA, that is less than Q minus 1. So this is a key generation part in from the Alice side. Next is encryption by Bob. Encryption is in Bob side. Decryption in Alice side. Okay. Encryption by Bob with the Alice public key. So we already generated Alice public key. So here let us take plain text as M, that should be less than Q. Select random number K less than Q. So if a message is long, then the message is divided into individual blocks. Okay. For each block key, that is K, should be different. Okay. So that is the robustness in this algorithm. So calculate K, capital K equals y a to the power of small k mod Q. Then calculate C1. C1 is ciphertext 1, C2 is ciphertext 2. Ciphertext 1 equals alpha to the power k mod Q. Then C2 is km mod Q. Okay. From that, what is my ciphertext? C1, comma C2. So this is encryption in Alice side. Then what is decryption by Alice? That is encryption by Bob, right? Then decryption by Alice with Alice private key. Okay, right. So here ciphertext C1, C2, you all know. Calculate K equals C1 to the power XA mod Q. Then plain text equals M equals C2 into K inverse mod Q. So from that plain text is a retrieve. Okay, right. So that's all about ElGamal crypto system encryption and decryption. Okay. So here the system is security relies on discrete logarithm, right? DLP, computationally complexity grows exponentially with the key size. So it is very sort of a strong technique used in digital signature algorithm, DSA algorithm, and PGP. So there is the main key features of ElGamal technique. Then applications, it is in cybersecurity, blockchain, mathematics, AI security. So that and all it is used ElGamal technique. And then this is the mind map. ElGamal Cryptosystems has used four concepts we have discussed: design challenges, technical insights, related approaches, and alternatives. That is ideate part we have discussed, and applications and links we have discussed. Thank you. Thanks for watching. We discuss with I come with another new topic in the next lecture. Thank you. Thank you.